Okay, welcome back. We're just going to go through some more questions. So we've got a few to go, so we'll just keep going with it. All right, so a tour guide has a bus that holds 100 people, maximum 100 people, so that's important information. Assume his profit in dollars for taking N people on a city, so it's a function of N, is this thing, okay? Although P is designed only for positive integers, right. All right, how many people should the guide take on a tour to maximise the profit? Suppose the bus holds 43 people. How many people should be taken on the tour to maximise the profit? So we've got some functions to work out. All right, so first of all, we've got 100 maximum people. So we've got this comparable interval, if you like, that sits like this. So we can't go outside that interval because that's just not the way this particular bus works. All right, the next thing we consider is P. So we'll write it in our form, if you like. So if we just do an expansion on this 50n 0.5n squared, so we'll get negative 0.5n squared, so just using that, and 50n, just putting it in our convention, and minus 100. Alright, if we go ahead and do the derivative, of course we want to set that to 0 eventually. We will have 2 comes out the front. Two halves of 1, so it's minus n, is unusual, 2 halves of 1, minus n, and we're left with 50. Okay, so that's our derivative. Okay, so it's a negative n, so it's a decreasing line, so that's interesting. So it's a max. Alright, so we want to assign Pn to 0 and solve. So that's something that we'd like to be able to do. Okay, so So 50 minus n, if we think about the interval idea, we've got an M curve, and we've effectively got a decreasing function, okay, minus n. Now when is this thing 0? We solve minus n plus 50 is equal to 0, so we'll add n to both sides. So therefore, n is equal to 50. At that point, we will find m equals 0. So that's our point here on your n curve. Beforehand, it's positive. Afterwards, it's negative. So what we're recognising is that that's a maximum. Of course, there's a change of sign. This represents a max. So we can answer the first, how many people should the guide take? Well, we better check the function for the endpoints. So P endpoint 0, let's put in the endpoint of the, so 0, that'll be 0, that'll be 0, and so we'll get minus 100, and for the other endpoint, 100 people, okay, we will get 100, 500, 600, half of 10,000 is 5,000. So I think I'll just check that with the calculator. I already do that to you. Alright. So we've got 100 squared negative. We've got 100 times 50. And we add that to the memory. And then 100 minus. Just do a memory recall. We see that we've got 100 as well. So we've got minus 100. Unexpected, but that's the way it's worked. And for our P50, so we're not making any money there. So with our P50, that's a maximum. What is the profit? So we need to put that in. So using the calculator again. So we've got 50. Just clearing all this away. So 50 squared times 0.5 negative. Pop that into memory. Then 50 times 50. Pop that into memory. And minus 100. Add that to the memory. Alright, so we clear all that away. We get 1150. So this is clearly a max. Even by comparison. Okay, so you take 50 for a maximum profit. So how many people? 50. Okay, so big hint. I think there's a question like this in the final exam. Alright, for part B, we want to say, suppose the bus holds a maximum of 43. So in this case here, we're modifying the interval. So we'll have to do a new calculation, okay, and 43. So it's not going to change our equation at all, okay, but 50 is greater than 43, isn't it? 50 is greater than 43, so we have to check this, okay, because 50 lies outside the interval. Okay, so we need to evaluate at new value. So in a sense, what I'm saying is unless 43 comes back with something we don't expect, then we're going to have to ignore the 50. Okay, evaluate at endpoints. So we know for n equals 0, it's minus 100. 55 doesn't come into it, so we've got to go through compute 43. So let's do that, 43. So we'll clear this away. So 43 squared times 0.5 negative. Pop that into memory. 43 times 50 equals, pop that into the plus to the memory, and 100 minus plus to the memory. So get rid of all that stuff, and all we do is pull that back, and we've got 43 gives 1125. So it would appear that although the number is less than what we got at 1150 for 50, we can't use 50 because it's not in the interval. So this one is the max. Okay, this one is the max. That's all that means. Alright, so we would use that one. So take 43. So that's easy. All right. Okay, that's it. Let's move on. All right, more applications. So we've got an object is thrown vertically from a 37 metre stand, so we better draw this. So it's sitting on top of a 37 metre stand, so it's like a rocket or a dart or something. Okay. It's got a cloud of exhaust where it goes. And it takes off and goes up. And the stand's taken away, so the object will fall away. Find the velocity of the object when it hits the ground. But we assume that it does some kind of maxi thing. Comes down, hits the ground. There's the stand. That's the ground. That's 37.5. Okay, so we've got height of 37.5. That's the ground. Okay, so we've got our formula, so let's find out what the... now, these are displacement. Now notice the displacement has been given a value, so we need to take that into account. Okay, so the initial position is 37.5. So when t is 0, that's the equation. That's why that equation exists in 37.5. So that's your initial height. Okay, so this represents if t ho if the height if t is 0, this thing is 37.5. Okay, so t equals 0, it's 37.5. All right, so notice that then the displacement function when differentiated becomes the velocity function. So I did a bit of a map when we did integration for this, so hopefully you recall that. Okay. Further, if we differentiate the velocity, we will get the acceleration. Okay, which is also the displacement function, second derivative. So there's a little chain that links along there, so you need to watch that. Alright, so we can evaluate a few of these different things because we know that it hits the ground. So there's some zero conditions that we'll have. Alright, find the velocity and the acceleration of the object when it hits the ground. Okay, so the first thing we've got to do is find t, because they're the 2 points. So we've got t0, 0 is here, and then whatever this hit the ground is, time the ground. You could call it 2 or whatever you like. Okay, so what are these 2 times? T0 and t hit the ground. So all we've got to do is assign this to 0 and we can solve that. So just finding the roots of the quadratic. Okay, so let's do that. So if we just say assign st to 0, not the derivative, just the actual displacement, then we'll have minus 4.9 t squared plus 49 t plus 37.5 is equal to 0. So this is purely displacement. This is not calculus. Be careful. Okay. So then we can use the quadratic formula or whatever we like to find t. Okay, and what we'll find is that there are 2 approximate values for t. Minus 0.71. I'll let you work that out and confirm that. Okay, which is less than 0. Just think about that. Okay, so that, what does that mean? And the other one is 10.7. So it's the bigger of the two. So that there is going to be the time to hit the ground. So that mark there is 10.7. 0 and 10.7. Alright, so how much time does it take and what's the velocity? Find the velocity and acceleration when it hits the ground. So we've got our time, so that works. So all we've got to do then is find our velocity, and our velocity is the derivative of the displacement. So all we need to do is take the, and that's going to be 2 lots of 4.9, which conveniently is 9.8. The linear function plus 49. Okay, so there's only going to be one place where there's a maximum, but we don't need to worry about that because we're not looking for that. We're looking for when it hits the ground. That was time to hit the ground, which is velocity function notation 10.7. So that's minus 9.8 minus 10.7 plus 49, which approximates to negative 55.9 meters per second. Whoa. That's very, very fast. Why is it negative? Because it's going down. The velocity is that way. So it's on the right-hand part of the curve. If it was over here somewhere, it'd be positive, but it's not. Wow, 55.9. So that's one part that we're interested in. All right. The next part is the acceleration. The acceleration is the differential of the velocity. Okay. So the differential of the velocity is going to be that bit, minus 9.8. Very straightforward. And because it's an acceleration, the units are meters per second squared. Okay, sometimes you see that written as meters less than minus 2. The acceleration that's occurring at that time of 10.7, it doesn't matter because there's no t term. It's still just this. Unusual, unexpected, that's right. I'll put it in the other form. It means the same thing. You know that from your indices. Okay, meters per second squared. They both say the same thing. Meters per second squared. All right, so it's determined because t is not in that particular one. So it's just the acceleration due to gravity. All right, so fairly straightforward. I think I'll come back for the last 2 questions. I'll be back soon.